let me start with a brief introduction of myself. I'm Francis Kenyuru. I'm currently working under Safaricom VAS. So I'm still new in VAS. That's why I took the initiative to be part of Natujenge. So I'll briefly walk you through M3UA. Basically, this is a SIGTRAN family, and it's used in telephone networks to carry signaling over IP network. It enables also SS7 protocols to be able to run over virtually any network technology, breaking basically the limitations to telephone equipment like the T carrier, E carrier, or the synchronous transfer mode. Then this comes up with improved scalability of the signaling networks. Maybe just to see some functions of M3UA. It supports support for the transfer of all SS7 MTP3 user part messages, which include SOAP, SCCP, ISOP, and more. It also supports. It has support for seamless operation of MTP3 user protocol peers. Also, support for the management of stream control transmission protocol, associations and the traffic between the signaling gateway and one or more media gateway controllers or IP resident databases. It also supports asynchronous reporting of status change to management. I think this it's just an overview. Just go back. An overview of how SS7 and SIGTRAN integrate together. I'll go to the core elements of M3UA, which I can start with the application server. Basically, this are running. This is kind of an address of a node running using SIGTRAN. This can be presented as a point code, and maybe a parameter of an application server is called the routing key. We have the application server process. This is the actual process running in application server, which normally maintains the SCCP association with PM3UAs. It also can connect directly to other nodes over the IP network, and also connects to other network elements via signaling gateway, or the SG. We have the signaling gateway. This is the interface between SS7 and SIGTRAN. It implements the SIGTRAN stack on the SS7 stack. Basically, as we had seen, SS7 uses the E1 or T1 connectivity, but now SIGTRAN connectivity is IP-based. So M3UA helps integrate now to SIGTRAN to enable SS7 now communicate by IP through M3UA. We have the signaling gateway processes. This is the actual processes running on the signaling gateway. We have associations, which refers to the stream control transmission protocol association. We have the IP server process, a process of an IP-based application. Failover. This is the capability of rerouting signaling traffic as required, basically due to maybe an availability of nodes or some of the application services. We have host. This is basically the platform that the processes run on. Run management, area management, a node of function that handles the input and output between the M3UA area and local management entity. We have the link set, a number of signaling links that directly interconnect to two signaling points, and more other elements in M3UA. Now we can briefly check on M3UA messages. We have protocol messages and user messages. Basically, as you can see here, we have the versioning, all the now elements that are in the M3UA message. So we have the version, the reserved, the message class, message type. We have things like network appearance, routing key, and the protocol data. We'll see them as we go on. We have now the message classes, which includes management message, data transfer, network management, the application server process state maintenance, also the application server process traffic maintenance, the routing key management, and also other values are reserved according to the ITF. So for example, we can see how the state maintenance messages are exchanged to make or to have an association setup. For example, whereby we have two application instances or application server processes wants to transition from state. Yeah. So we have an M3UA signaling gateway and also an application server process where they're exchanging messages to bring up a link. We can also see a traffic maintenance message, whether they want the link to be active or inactive. We have also the network messages in certain conditions. Basically, application server, once an application server is active, it can send or receive messages to or from other point codes in SS7 via signaling gateway. The point code or the SSN status may change on a signaling gateway for a node in the SS7 network. We have various messages, destination available, where a message is sent from the signaling gateway to the application server for a point code which is no more available from the signaling gateway. Destination available. We have the destination audit, signaling congestion, destination user pattern available, restricted message, and finally the user data message. We can see a simple exchange of messages between an M3UA, something to do with the application server instance and application server, and also a signaling gateway, how the transition happens for a connection to be active and now data to be exchanged between the nodes. Then we can briefly talk about the protocol elements. We have the data message contains the SS7 M3UA user protocol data, which is MTP transfer primitive, including the complete MTP3 routing label. The data message contains the following variable and parameters. We have the network appearance, which is optional. Also, the routing context is optional, and the protocol data is mandatory, as we will see later. We have also correlation ID, which also is optional. So maybe we can try check a few things. And the network appearance is 32 bits and side integer, routing context 32 also. Protocol data is a variable length, and the protocol data parameter contains original SS7 MTP3 message, including the service information, octet, and routing label. The protocol data parameter contains the following fields: service indicator, network indicator, message priority, destination point code, originating point code, and also the SRS, which is the signaling link selection. We'll see these fields when we walk through a Wireshark trace. This is just a parameter, the protocol data parameter in encoded format. We can see things to do with the M3UA needs to, these are procedures in M3UA. You can see receipt of primitive from the M3UA user. For example, on receiving an MTP transfer request primitive from an app area at the application server process or the IP signaling point. At the node interaction of the signaling gateway process, the M3UA area sends a corresponding data message. These are basically the procedures that happen in the M3UA protocol. I think last time we had talked about SMS. I can just briefly highlight on maybe a recap of what we went through last time with the other groups. And I say SMS about 160 characters. It's not real time. It uses to and forward method. We can either send messages using the GPRS, the GCF network. We have types of messages: peer-to-peer, this is subscriber to subscriber, application to to peer. These are messages. Example of a message is when you go to the bank, you do a transaction, then a message is initiated from the bank end to you, the subscriber. We have the peer to network. These are example of giving services where you need to maybe send a certain keyword to a certain shortcode so that maybe you can do some gaming or some music online. We have internet to peer. These are examples when you sign up in a Google account and maybe an OTP is sent so that you can either authenticate or you being authenticated to either log in or do something. I think that we have just discussed network elements. We have the SMSC, VRL, MSC, HRL, BSC, BTS, and such. I think we can just walk through an MO journey of a message and also maybe an MT where we have message originating from a mobile subscriber through the base transceiver station to the base switching center to the mobile switching center. Then maybe a profile is checked on HRL. Then message is forwarded to SMSC for storage. And now for termination, I think the journey back is SMSC to MSC to the you are serving BCS and also to BTS, then back to the mobile subscriber. I think this is an explanation of the entire SMS process from MO to MT. This I think we had gone through. We have some of the condition around the journey, absent subscriber, non-subscriber, headset having an issue, and also maybe sometimes subscriber is busy for message termination. These are a few facts about SMS. Yeah, I think we can go back to maybe an example of application to pay a message. How it works. You have an application with a messaging platform. For example, in this case, a bank sends a message or a multimedia message to a mobile network operator, which now through the MT journey delivers the message to the mobile subscriber. We have also the A2P message flow call from there. Then I think we'll have a look of various traces of a Wireshark. Let me just, I think we can now walk through the M3UA area on the one of the Wireshark traces that are provided. So let me just open this, and now we check under the M3UA, the MTP3 user adaptation layer. We can see various parameters here. As we have seen, we have the version, the reserved, the network appearance, the routing context, which the network appearance and the routing context, we see they're optional. It depends maybe on the vendor of maybe, for example, of a certain system. And also we have the protocol data, which contains the SS7 message. I'll just briefly copy the hex stream of the M3UA so that we can try check on sample. We try decode and see whether we can figure out what these parameters mean and how we can obtain them from a hexa stream in an Wireshark setup. So this is invoke SRI. This is basically a request to HRL to send the routing information. I'll paste my hexa stream here so that we can try check on it. From our Wireshark perspective, let me try to see whether I can split the screen so that this becomes easier. We can see basically, let me just do this here. We see the first two. I don't know how I can call them, but allow me to call them. This maybe is just one octet, which represent the version, which is basically this one, version 1. So this we can decode it as the version, and basically this is 1. As we can see, this means it's 16 raised to power 0, which is 0. Since this is in hexadecimal, so this is an equivalent of 16 raised to power 0, which is 1, times 1, which equates to 1. We have the reserved, which is basically reserved bits. This is equivalent to this here, which is 0, 0. This is reserved. Let's say this is reserved bytes. This is 0, so this automatically equates to 0. We have the message class, which is the transfer messages. This equates to 0, 1 here. You can say this is the transfer message. This also equates to 1, since it's, what did I do here? Let me just see. I think it was 0, 1. Then we have the protocol data, which also equates to 0, 1. Basically, 0 means maybe this is should to form an octet should have a preceding 0. This is just added to make it complete. This is the period data. And then we have the length, which translates to up to here. These are basically 8. This is an 8 value. I think these are around 4 octets. This is the message length. So basically, let's try decode this. I think C stands for, don't know whether it's 12. Yes, it's 12. So this means it's 16 raised to power 1 times 8. So this is multiplied by 8, then plus 12. I think someone with a calculator can guess this comes to 140. Let me just calculate.
Yeah, it's 140.
Yeah, so this is what we did here. Then from there we go to the routing appearance, which contains, I think in the previous session, we had the TLV, the tag length value. I think it follows that suit. And as we had discussed, this is an optional parameter. It depends on the vendor of the maybe a service. If he decides to put them, it's okay. And others may decide not to include them. We just check that later before. So the parameter tag, it goes to this here. Let me just see up here. So we can see from here, this is the network appearance. Then we can decode this as this is 16 squared times 2. So this is 16 squared, then we multiply by 2.
512.
Yeah, so this is 512. Then from there, we can go to the parameter end. Parameter end equates to these 2 octets here. Someone can clarify if these are 2 octets. I'm saying my own things. They are not as easy as they seem. So this is the param length. So this basically means it's 16 power 0, which is 1 times 8. This equates to 8. Then we have the network appearance, which is, this is the value. The value comes to 8 characters here. So I think up to there, this is the value, or the network appearance value. I think now from there we can go to the routing context, which is also an optional parameter, as we have seen. Also here, when we open this, we see it follows suit with the tag length value. Then I think we can try now decode this with the first 2 octets here. This I think it's equals to the tag of the routing context. This is basically 6, since it's 16 to 16 raised to power 0 times 1, which is 1 times 6. Then we go to the parameter length. Parameter length equates to 2 octets here. This is basically the param length. Then this equates to 8. So as we had seen, then we go to the routing context, the value of the routing context, which goes up to where we have this. Then this is the value. We can try to decode this. This means f is 15. We add 16 times 2, since the second value, we check from the right to left, the second value is 16 raised to the power 1 times 2, so this is times 2. Then we add 1, which is 16 squared. 16 squared, allow me just to write it this way. Then this times 1. So I think this will equate to 303. There's someone with a calculator somewhere trying to help me out here. I'll just confirm that. Then try this by 2. Did I do it right? No. I did it wrong. The second one, it was supposed to 16 multiplied by, it's 16 raised to power 1. So raised to power 1 times 1. Then we have no, this is
yeah, it's okay.
So from there, now we come to this mandatory. This is the mandatory parameter, which now includes the values, the destination, point code, the originating, the service indicator, network indicator, the message priority, and also the SRS. And now it also includes the equivalence of the SS7. So we'll decode this very fast. We have the protocol data here. Let me just put a division here. We have the protocol data, which contains the SS7 representation. So this is the 84 suite. Yes.
You can wind up a bit so that the other groups also get a chance to present.
Okay. So basically, when we follow suit, we'll see now the protocol data of the representation of the SS7 message with the below params. We have the parameter tag, parameter length, originating point code, destination point code, the service indicator. We have the network indicator, the message priority, and the signaling link selection. And we see also the equivalent of this. So basically, when we see our message will come up to a point like this, then from there we have now the other body. The remaining body is from now the signaling control part. I think this is meant for another group. So basically, as I had said, let me just try expand this and see how, as I was explaining, that the network appearance and the routing context are optional parameters. For example, when we see the acknowledgement from HLR, we can see briefly that the routing context and the network appearance are not visible here. That means the optional parameters and maybe the vendor for the request, maybe from SMSC to HRL, is different from the vendor from the HRL vendor, since maybe one decided to include the optional parameters, and the other one just decided to ignore them. So I think I'll stop there. Thank you for listening. Thank you. Back to you, Marian.
Thank you, Francis. That was a very elaborate presentation. Group 2, Mike?
Actually, Marlin,
yeah,
I don't know whether, before people forget, because it's very extensive, I don't know whether we should give Collins a chance and Walter a chance, just to also help us navigate this thing about M3UA. What does it maybe from their own perspective also, before we forget, because I know the moment we get to SCCP, we might have forgotten about network appearance and signaling link selection.
The presentation was good. You started well, and I like it that you were able to drill down to even what we need to understand for successful decoding of the signaling message, which is one of the things that will be expected as the project progresses. But I think there are some parts that you rushed over. So basically, the main thing is maybe time management. You need to look at the time management as you present. Because for the call flows, you really didn't explain much. You just rushed over it. But I like the fact that you're able to go through the decoding coders on that. Thank you.
Okay, Collins, just to make a comment, I think one of the comments is, I think it was on the SMS type. There's one that was missing. It's called A2A. It's application to application. It actually exists where you might need to route a message from one application to another application. So you can add it. Then around the Wireshark presentation, I think it was great because at least you try to break it down into the different levels under the MTP stack, and just to add maybe for guys to understand, under the point code we have the OPC, which is the originating point code for the sending application, and you have the destination point code for the application that needs to receive that message. Like for your case, I think I saw it was 12.6.27 or something close to that. That is the originating point code. So that means that is the identifier for the SMSC, for the MTP connectivity, and that message needs to be sent. The destination point code for that message is 12. I think it was 12.745. So that is very critical at the MTP layer, because it means that at the M3UA, that is the originator of the message, and the destination is the DPC. It might be the node that do it at the SCTP layer, or might be a different node. So that is more of what you are addressing at that layer. So, and also the SLS that Kamochu highlighted about it, because you find that when you are at the M3UA level, you might have several links. So the SLS sort of identifies the link that that message was routed through. Like I think the trace that you gave was it number 15. So that means that the link selection was number 15, and I think it usually starts from 0. So it means that that was link number 15 in terms of the MTP, but in terms of counting, that was link number 16 from the SMSC side. So that's just my input from my side. We can maybe go to group 2. Thank you.
Maybe Collins, before you disappear, I have heard,
Yes.
I think the things that you guys are highlighting, that maybe for the guys who are very green, I've heard you mention the link, we've heard you mention point codes, you've heard you mention about link sets and the selection. Maybe what do those things do? And if possible, if you can relate it to what we understand, because I think some of the guys could be looking at it as a very foreign concept. But if you can help us figure out what are the key things we need to remember when we talk about M3UA.
Okay, a point code, you coming from an IP, that is like an IP. That's more of like an IP on the network. Let's say you have an IP address of 192.168.1.1. That is your IP on the LAN. Now, when now you go to SS7, a point code is I can put it like an IP reference. So it's sort of what identifies a network element on the SS7. So you'll find that if you and within a certain network, you don't have this. You are not supposed to share a point code the same way you are not supposed to share an IP within the same LAN, or else you'll have an IP conflict. The same way also on a network, the point code must be unique. So you'll find that an SMSC will have its own point code. HLR will be identified by one or many point codes, but a point code identifies an element on the network. So it is every node has its own point code, and you might have instances where you can have certain implementation. You might have several SMSCs sharing a point code, or you can have individual SMSCs with their own individual point code. And so I think I've tried to explain it. So you look at it like an IP on the network. That is what a point code is. Now, when you go to the SLS, that is like, now when you define your links, look at them like routes. Like you say you want to go to town. If you want to go to town and you're coming from Wayaki, you can use the Lower Kabete route, or you can use the main Wayaki way, or you can decide to use maybe some routes through Lavington, but you will reach town. But now on the network, when two elements are talking to each other, they need to know which route did you use. So sort of that when SMSC is sending a message, among the many links that it might have, like many routes, it needs to select a certain route that I need to terminate that message through. So when SMSC needs to talk to, let's say, STP or HLR, where they are connected to at the point code level, you'll find that when you are creating your logical links, you might have, let's say, 4 logical links. It means you have 4 logical paths that you can use to transmit a message. And the SLS are important also to decide if you have also a link that is bad. Because if, let's say, you have 4 SLS links and one of them has a problem, you still have 3 other routes that you can use them to still reach down. So those are, I hope I've tried to explain what SLS is and what a point code is.
Yeah, thank you so much, Colin. It makes sense because we are here to understand some of these jargons. I know some of us have read so many documents. So when you complement that with what we understand, I think it has really brought some light to me, and I hope to other people. So Marlin, maybe we can, maybe one of the things that Grace is in the vicinity mentioned, when you think about the point code, and I know, Collins, this is something that you guys do. It's like the unique identifier of that node within that network. So you might find that because a telco network is a private network, so within Safaricom there are many nodes. Each of them has to have a unique point code. But you'll not be surprised to go to Airtel and you find they are reusing the same point code for another network element. So it's within your network, like your private network. And she also told me that there is another identifier or an address for a node if you're looking at it from an inter-networking layer, which is now global title, which I'm hoping my brothers and sisters from group 2 will help us appreciate. So I guess I have delivered the message as requested. Marlin, over to you and the team.
Thank you. Group 2, Mike, are you here?
I'm here. How are you guys?
We are good.
I'm Michael Wanjiru, and I'm going to talk about SCCP. I don't know if you can see my screen. Okay, so it's decoding SCCP. About understanding SCCP, SCCP is an abbreviation for signaling. Sorry about that. Sorry about that. So let me start over again. So SCCP is an abbreviation, signaling connection control path. It should not be confused with the skinny client protocol, control protocol for in the Cisco, in the entire Cisco. The signaling connection control path provides reliable delivery of packets between end station in a telephony network. SCCP also makes it possible to address a message to a specific type of device, such as conventional telephone sets, cell phone sets, voice over IP, end station, fax machine, or even computers. SSP also stands for, as I had already mentioned, the skinny client protocol that is used by Cisco between voice over IP and endpoints. So, some of the functions of SCP are and extended routing of the MTP3UA layer, MTP-UA layer. It also provides communication with the DP, the database, that is the HLR. This is during location updates. It also deals with segmentation when the data segment is bigger than one network service data unit. That is the maximum that the data can hold. Okay, most of the time, SCCP is also used as a transport layer for services such as the emergency services, which provide free phones. They're also used for phone cards and roaming in cellular networks. SCCP also supports two network services and provide 4 classes to its applications. The first one is connectionless, which has 2 classes, that is class 0 and class 1. A connection oriented, which is basic connection, which is class 2 and class 3. If we are to look at a connection oriented, in SCCP, the point that starts with the message known as pardon me, please. It requests with a confirmation request from an SCCP user on a connection-oriented data service in the originating SSP. It sends a confirmation request message to the SSP located in the SSP2. On receiving the message, it returns a confirmation message to SSP1. Then after that, with the known values of the SLR and the DLR, a logical connection is now established. With the logical connection established, data transfer can begin, where the user data is transferred in data forms, DT1 for class 2 and DT2 for class 3 on a connection oriented. And on completion, a release message is sent to the SSP2, which returns with which a release message is received on temporary connection sections. This also, the reset timer is also stopped. These are some of the messages in a connection oriented service: connection request, connection confirm. There is also connection refused. There is the release. There is release complete. There is data form 1, data form 2, acknowledgement, unit data service, expedited data, acknowledgement, reset request, reset confirm, and error. Then there is an inactivity test. The CO transfers many or long signaling messages between 2 nodes. In this case, it makes sense to establish a logical connection between the sender and the receiver. The connectionless transfer short messages, including routing information to their destination. And since these we are dealing mostly with SMSs, we are going to mainly deeper in the on the connectionless. So in both class 0 and 1, the connectionless services sends the message between SSP users are transferred without establishing a logical connection. Each message is sent independently of the previous, on the previous message. The SSP user data is sent in a unit data message. Okay, the difference between the two is that class 0 and class 1 is that class 1 tries to offer but not guarantee in sequence delivery by setting up the same SLC code for messages in a transaction. Okay, now from the chat there you can see that an SSP user sends a end data request, then which is then the UDT messages from an SSP to an SSP, and then the same is for the return. Connectional classes provide capability that are necessary to transfer one network service in the data field of an XUDT, an LUDT, and UDT. If the data cannot fit in one network service data unit, it is segmented and or reassembled. If it is the originating node, it is segmented. If it is the receiving node, it is reassembled. This can happen either in the originating node or in the relay, right? The node provides segmentation prior to data transfer. Procedures for connection and service. When the SSP functions at the originating node receive from an SSP user and execute the transfer of the protocol class 0 and 1 connection and service, the call address and the other relevant parameters, if required, are transferred to the identity node towards which the message should be sent. The network service data unit is then included in the data parameter in the in the message type, which is sent towards the node using the MTP routing functions. Upon receipt of the data message, which can be either be an XUDT, an LUDT, or a UDT message, the SSP functions at that node perform the routing analysis as described. If the destination of the XUDT of the message data is a local user, it delivers the network service data unit to the local higher layer functions. If the destination of the message data is not at that node, then the XUDT, LUDT, or UDT message is forwarded to the next node after a possible change of message type. This process continues until the destination is reached. Now let's look at the message format. Now, a message format, an SSP message will include a routing label, a message type field, a mandatory fixed field, a mandatory variable field, and an optional field. Now, these are some of the parameters in an SSP message. There is the message type, there is the class type, there is the pointers to the mandatory variables, which are mostly they are the pointers. Then there is the address indicators, and in the address indicators we have the routing indicator. We have a global indicator. We have a subsystem indicator. Or this a subsystem indicator, which is a number, may be compared to a port number where our port number in TCP. In TCP/IP, sorry, there is a point code indicator, and there is also a global title. In the global title, there is an address indicator, and the address indicator coded as national. Now let's look at an SSP message from Wireshark. Let me share something else. That is the SSP, and these are okay. It has the following parameters. They have said the message type, which is 1 octet. It has the class type, which is also 1 octet. It has the message error return. It has the pointers to the first mandatory variable, the pointer to the second, and the pointer to the that. Okay, now let me pair it with the whole with the whole so that we can see. So we look at it from, when we look at it from this perspective, the first octet represent the message type, represent the message type, whereby in this case 09, when converted to, when you convert it it will be still 09, which in the form document, in the document, represents the unit data. The error type, okay, the error type, okay, there is a return type, return error, the pointer. Now the return error is also 1 octet, so there it is. Then we'll
Actually,
yes,
the return error together with the class are encoded using 1 byte. So the first digit, the four bits, which is a nibble, is actually the return is the return error. The message handling thing, which is 1000, which is 8, and the second digit, which is 1, is actually the class, which is class 1. I have seen from your dump. So it's 2 parameters encoded into 1 byte. The first 4 bits to the right, or the less significant bits, they represent the class, and the higher order bits represent the message handling, which is set to 9, meaning that you should return a message on error. So you're telling the other guy, in the event there is an error, please ensure that you return the message. But I just wanted to mention that it's 1 byte split into 2, meaning it's 4 bits representing the different fields per se.
Okay, thank you. Okay, now these are the one. These other one represents a pointer to the first mandatory variable. Then these 3 points are the pointers, which is that part. Correct me if I'm wrong. That part, and there is this one. So when we convert this one, it takes us to the third. When we check this one, it takes us to this one is 14, and this one is 25. So for the first one, it's okay. I've already cut them, so it is that. Okay, if you were to count them, it would have been here. It starts from here, right? But this one here, it's the length of that variable. So 0b, if we count the call party, it actually tells us it's okay. It's 11 bytes. Actually, this one, the length. This is 11 bytes.
Just a comment.
Yeah.
Just a comment. The 3, which is the pointer to the first mandatory variable parameter, it's just basically saying when you count from this position, so like 03 will be position 0, then the next 0E is the next position, then 19 is position 2, then the next will now be the mandatory part. So the mandatory part starts from the length.
Yeah,
I don't know whether that makes sense.
Yeah, true. Yeah. So as he has said, this okay, if we were to count, when we get the 3, this is 0. So this is 0, this is 1, this is 2, and this is 3. So it starts from here. It starts from there, and we have found the length, which is 11. So when we count to 11, that is 1, 2, 3, 4, 5. Okay, let me. I had already cut some, so let me see. And here, I think it's there. Yeah, it's there. So again, if we check the second parameter, things start from 14. So from where it is to 14, it will be here again. So, okay, yeah, it's there. Then there is the third one, which is at 25. So from where you are, the 11, this one 11, and they're like, yeah. Let me just. It's a quick one, so it's up to there. So then there is the final parameter. Now, okay, now when you come to these parameters, there is the call addresses. which has the address indicators, and in the address indicators, it has the some routing information. It has the global title indicator, it has a subsystem indicator, it has the point code indicator, but in this one you see that the point code is not present. And when the point code indicator is not present, then from the documents, the global title indicator must be present. The two of them cannot be absent. One of them must always be present must also always be present. It's a mandatory variable. Okay. Then we have the subsystem number. Okay, let me see. Then we have the subsystem number. Now, in the global title, this is where we have the caller's ID. The caller's ID, as you can see, that is the caller party digits, which gives the phone numbers with the country code. So when you convert, okay, let me come down to a point where I had already kind of highlighted which ones they were. So there's the address indicator, the subsystem number, then there's the global title, which has the nature of the address, and now it has the calling address. So now that's the complete calling address together with the country code, and that is the same as the calling party address. It contains the same information as the called party. The calling party and the called party all have the same information, the routing information, the address indicator, the point codes, or the global title indicator. Now, one of them should always be present. And there's a closing. Okay, so I'm trying to find it. Yeah. I know my presentation is kind of shallow, but that's what we have for you. Thank you.
Oh, thank you so much, Michael. I think I will allow then Walter, and I'm acting as the deputy president to Marlene. Yes, so I'll allow Collins and Walter maybe to comment and also just tell us what we need to remember when we talk about SCCP. Why does it even exist? And this is just to enhance what my brother Michael Wanjiro has done, which was quite extensive. I can borrow Marlene's view from the previous speaker.
Collins, you can take the floor.
Oh, okay. I think that was quite extensive. That was great from I think Michael. Okay, SCCP is so critical nowadays that because SCCP is where actually most of the magic happens. That's where actually how we interconnect more of the networks. Even within, if you want to route messages within Safaricom or even out talking to other network, it actually simplifies some of the limitations that we have within the MTP3 stack, because you find that when you come to SCCP, it's easier now in case you want actually to route a message from one network to another network in a very simplified way. And just maybe to make it to try and differentiate what is a point code, the difference between a point code and a GT, I'll try to give an example. When you are within Safaricom LAN, you have that private IP that you have, which is a 172, or when you are within your own university LANs, you find that you usually have a certain private IPs, or when you are on a Wi-Fi. Now, if you need to access information out there, you find that most probably you will hit a public IP. So look at it like the point code is that private IP that you have. Now you want to access a certain public URL out there. Now that public URL has a public IP. Now that public IP, look at it like now the GT, because that URL has a public IP which is unique in the entire internet. There are no the public IP is not repeated. So when your message leaves this your internal IP, you are addressing a public URL out there. So it's like you are routing your message based on GT. So you are saying that I want to access this GT. So all the network elements from your laptop to the router to firewalls out there, they will be trying to route your message for you to access a certain URL out there. Now that's what happened when you are routing based on GT. So you are telling the SS7 network that I want this message to be terminated to this specific GT. So it's like a specific public IP. So all these network elements will try to route your messages to that GT that you are addressing. So I hope I've tried to give an example that makes sense. Or like a post office, when you want to send a message, when you want to send mail, you will write in the mail that I want this mail to be sent to Collins Ocheng, and he is located in Eldoret, and this is the box number. So that box number sort of is unique to me. So the box number will be 221 Eldoret, Kenya. So when you try to send that message, maybe from the US, so US will say that I have this mail that needs to be sent to Collins, whose box number is 221 Eldoret. So all the postal handling along the way will be trying to route that mail to Collins, who is in Eldoret and is located at a postal address 221. I hope tumeelewana hapo hivyo.
Yeah, that makes sense, Collins. And maybe one of the things that I have borrowed from Michael was, I think there was at the SCCP layer, we can see two mandatory parameters, which are the variable parameters, which is the called party and the calling party address. So my assumption is that the called party and the calling party address is equivalent to the source IP and the destination IP, right?
Yes.
I mean, if you're coming from a background of IT guys who understand the two IPs, the destination and the source IP.
Yes. So you will find yes. So the called party is like the IP that you want to access. It's like the GT that I want this message to go to. Then the calling is the requester. So for like the TCP dump, the calling party will be the SMSC GT, and the called party now will be, in case of it is an SRI, it will be you'll be asking for an MSISDN if you are routing on GT. If you are not asking, if it is something, if you are terminating a message, it will now be the MSS. And you know, the calling and the call is critical for now the network elements to respond also back. That in case now, in case anything happen, like there's one of the layer which is to that message along the way, they know who to respond back to, and the guy who the network element should respond back to was the previous guy who was the calling. So the calling will be now with errors, or you need to give back response that the message was successfully terminated. So you find that usually those fields are now switched, that now the MSC will now respond back. The calling will become the called, and call will become the calling.
I just wanted to highlight one thing. There's something that might be confusing to those who are still new. that whatever you saw as the global title, it's not actually the telephone number, but it's an address of the node. So if it is the SMSC, it's the address of the SMSC. If it is the MSS or the VLR, it is the address of the VLR. It's a globally unique address that has been assigned to that node, so that it can be that can be used to identify it from wherever network we are in, wherever we are. The same way public IP once assigned to a resource, a computing resource, it can be used to identify it from wherever we are. Back
Thank
to you.
you so much. Yeah, thank you so much, Walter, on that. I think there was another element that Mr. Michael brought up, which now makes sense when I remember when the guys were presenting the SIGTRAN track, there was a bit of a confusion because we used to talk about MTP3 does the routing, and we can think of how the network route, the internet, it does a bit of routing, but it was a bit insufficient. And now I see why some people are saying that SCCP was also brought in to help us fulfill the layer 3 functions of the OSI model within the SS7 network. So I have seen that the SCCP also takes care of a bit of routing, addressing of nodes. You know, you have the source GT and the destination GT, or the called party GT and the calling party GT. But then I also saw from what my brother represented is that it also looks like SCCP is a brother to TCP from us who are coming from actually it's a brother to both TCP and UDP, because it can do both connection oriented and connectionless. And connection oriented, we saw where we were being told, you know, connection request and the connection confirmation, which is equivalent to the handshakes within TCP when we say the 3-step handshake for us to establish a connection, and then sending of data, and then later you can release the connection using the primitives that TCP offers. We can also see the same on SCCP, and we can also see connectionless. And I was happy to know that we don't need to focus on a lot of headache when you're dealing with the SMSC development, because we don't need to deal with connection-oriented primitives for now, because my brother confirmed that it runs on connection-less communication. So you just fire the SRI, you don't have to establish an SCCP connection. Maybe you can help us grasp that also, Collins and Walter, and maybe you can correct me in case there is a misunderstanding that I have from what has been presented, or strengthen in case my point is valid. Collins and Walter, would you like to add a comment on that function of SCCP as to help us achieve those connection oriented? And you can tell us even where they are used, because I know SMS runs on connectionless. What services run on connection oriented? Maybe you can shed some light from your experience.
Okay, you are right about SCCP simplifying things, because before, if we SCCP helped us to, especially if you do SCCP and you do routing based on GT, it simply, because initially, if you look at where you had to route based on point code sort of, you find that SMSC had to know so many network elements. You had to know that you actually had to sort of like have a mapping that in case I need to terminate, let's say, to a customer is MSS 01 and another customer is on MSS 02 or 03. Initially, SMSC need to know that how do I need to reach MSS 01, or how do I need to reach MSS 02 is I need to terminate messages. But now when you now do routing based on GT, it simplified things, because the C doesn't need to know you do not need to have those connections sort of to reach MS2. You just there is an element that Walter is aware about. We handled it, which is the STP. So SMSC, I just need to connect to one or two STPs, and the STPs is like a transfer point for me. So the SMSC now, I don't, initially SMSC needed to connect to each and every MSS. You had to connect because you had to do routing based on point code. But now when you go to routing based on GT, I just need to terminate a message to the STP, and I'll just inform the STP at the SCCP layer that I have a message for this point code. Can you deliver, no, for this GT, can you deliver this message to that GT? And then the STP is down that now many elements behind it, and it will just terminate it based on the if the subsystem number for that message was the HLR, it will know that this message I'm supposed to take it towards the HLR. If it is the MSS and I can see the GT is within the network, I just need to terminate it to the network. In case the GT is not a Safaricom or within that network, you now know that now if it is for an international message, you now terminate it through the international gateway. So it simplified, the SCCP simplified most of the pain points that used to be there before. So I don't know, maybe Walter can add something around what SCCP does.
So, sorry, I got distracted, but basically the introduction of SCCP was to extend the routing capabilities, because the original routing, that addressing and routing that was being done on point code, as we know, point code is or the one used by the ITUT format is 14 bits plus 14 plus 2, 14 bits for the point code and 2 bits for the network indicator, and that limits the number of nodes we can uniquely identify when using point code, because for 2 to power 14, I think it's not a very big number. So in order to extend the routing and or extend the addressing, SCCP came in, and now with the SCCP, you can have flexible routing. Collins has talked of something we call STP. It's similar to having an IP exchange point for the guys from the IP world, where if you want to reach certain networks, you just send it to the IPX, then the IPX should be able to route it out. Or maybe instead of IPX, you can say similar to having maybe your internet service provider. Whatever you don't know, just route to the internet service provider, and you expect the internet service provider to get a route to the actual network. So SCCP actually simplified routing, and it actually extended the number of nodes that we can address within the signaling network. And one more thing, sorry, let me take you back to M3UA and MTP3. On the addressing, we have 4 networks. We have what we call the national reserved network. We have the national network, international network, and international reserved. Now, for international network, those point codes will be unique. However, there are very few. I know in Kenya, the 3 major operators that we have in Kenya have only 2 international point codes each, and that would not be enough to identify all the signaling nodes that they would want to use. And the only that because the number that ITU has given to CAK, so that CAK can distribute to the local operators are few. So that's why you'll get there very few point codes. The ones on national network is also regulated by the regulator. So CA, Communication Authority, issues some sets to some networks. So they'll give Airtel some, they'll give Safaricom some, Telcom some. However, this would also not be enough. So you'll find national reserved. Most networks also pick point codes from national reserve that they can use as they wish. They don't need to talk to the operator. It would be a similar concept to the way you can pick an IP address from a private IP pool. You can use as you wish. However, you can never share it with any network outside. You can never share it with any network outside the network. National reserved is international reserved is also reserved, but there are also networks that pick them and use them internally, but cannot be shared outside. Back to you, Kamocho.
Thank you so much, Walter and Collins, for shedding the light. I would probably, I know time is not on our side. We have many groups. Not everyone has gotten a chance to present, but unfortunately, we've just had a consultation with Marlin. We might not allow any other group to present for now. So we will agree on the group when we can have the next presentations before we move on to the next challenge, which will be basically to write the code to actually decode the layers as you guys have mentioned. But I would ask anyone with a quick question to our guests and our mentors. Maybe we can give you a chance so that we don't lock out someone who had a very small missing gap that they needed to connect. Yeah. I think silence means that we should be okay. Yes, the key idea is we are learning these things so that we can become better engineers and we can develop these applications. Definitely the concepts are not very foreign. Today we heard about a thing called associations. Unfortunately, we didn't manage to look at SCTP protocol, which is a sister protocol or a brother protocol, depending on how you look at it, to TCP and UDP. So SCTP, or Stream Control Transfer Protocol, I guess, or something. So the whole idea is when Michael mentioned about associations, that is a word that comes when you're talking about SCTP layer. M3UA sits on top. And then we have on top of M3UA, we have seen SCCP, but each of those layers have their functions and we must operate with them if we are going to build an SMSC. So we have two more layers that are very critical on top of SCCP, and we have TCAP, or the TC, some people call it, or transaction capability application part. And finally, we have the GSM mobile application part, which will allow us, for those of you who thought at the SCCP, the number that was there was mobile number, that is not correct. The mobile number is actually a parameter within the map. And I know there is a group that is working on that. So let's keep learning. Let's revisit the videos. Let's go back to the conversations that we had previously. And thank you guys for the love. We can see quite a huge turnout, and it's a very complex subject, as some of the mentors confirmed previously. It's not one of the easiest, but nevertheless, we are happy that you guys are bold enough to come and have this conversation. So Marlin, I'll hand it over to you. And I would like to thank Collins and Walter for helping us, and also to recognize one guy who is also he disappeared, so I'll not acknowledge him. But my friend Chano Piach was here, so he has disappeared. Marlin, over to you as we end now. The next presentation, we will agree on the group with the leaders, and then we can approach the industry professionals. We have a lot of them in the group, so if Collins and Walter are not available, we are sure that we'll get other guys who can also listen to you guys and appreciate what you're doing. Very critical analogy. Like today, my parting shot is SSN is the equivalent of the port when we talk about our systems. Like port 80 is the port that we use to identify the web server that runs on our servers. So if we are running the service database that has the SMSC. Then there is an SSN number that is assigned to it. So the analogies are very critical for us to appreciate. Then we will see what we can do so that we can progress to the next level of developing our stack and also developing the applications.
Hello,
Oh yeah, I forgot to recognize Grace, who was in proxy. Yeah, we also acknowledge the fact that Grace is in proxy listening to us, also from the Nairobi professional community. Thank you.
Okay, thank you to everybody who was in attendance, to the mentors, and also the participants. We unfortunately can't finish all the presentations today. Sorry to all the group leads or group members who put in quite some work to be able to finish the presentations today. But group 3, 6, 4, and 8, we can agree that next week, that is what we will be starting on before we move to the next challenge that involves development. And I'm seeing quite a number of new members here. So if you have any questions, you can chat me on the WhatsApp group. You can DM me for any questions. Anybody who is new and wants to be part of the challenge, you can reach me or Kamachu, and we'll arrange something. So that will be the end of the presentations today, and we will communicate further when the other groups will be able to present. So thank you to everybody who was in attendance, and see you soon. Goodbye.